This chapter is about the interior of the Earth. When we say interior, we are talking about the inside of Earth. So if you are familiar with this diagram, the different layers of Earth, that is the core, mantle and crust, these all together make the interior of the Earth. And there is a constant change that is going on inside the Earth. Knowing those changes requires us to understand the interior of the Earth. That is what we are going to learn in this chapter. The landscape that we see around us is a result of a constant endogenous and exogenous processes. So endogenous means internal and exogenous is external. Now internal processes such as volcanic activities, folding of the crust and faulting due to plate tectonic activities. So all these processes change the landscape and they are collectively known as endogenous processes. Now exogenous processes are those activities like weathering, erosion, transportation, deposition, denudation. All these acts causes changes to the outer physical shape of a landscape. The main reason it is important to know about the interior of the Earth is due to the fact that human settlement is largely based on physiographic conditions of a region. That's why you will see in plain areas the population is more compared to hilly and mountainous region. Now we have seen a lot of times due to natural calamities like flood, landslide, there's a huge risk towards human life as well as properties. And if we know why the Earth shakes or how a tsunami wave is generated, that will help us in creating necessary mechanisms that will protect us from any of such natural calamities. Again, going back to this diagram about different layers of Earth, scientists have gathered enough information and various characteristics about each of these layers. So this chapter will basically help us know more about these layers. Let's read some information about the interior of our Earth. The Earth's radius is 6,370 km and no one can reach the center of the Earth. And it is obvious as to why we cannot. So in that case, we only have two ways of collecting information about the interior of our Earth, and that is through direct observations and analysis of materials. First, let's know about some direct sources. Under direct sources, we have rocks that are like a strong evidence which we can use to know the interior of the Earth. The rocks that we see on the surface or the rocks we get from mining areas, they all speak something about the interior of the Earth. But it is generally said that if we can get some rocks that are direct from the interior, we have better information that will lead us somewhere. Because the surface rocks undergo constant weathering due to rain and wind, hence it is not as good as an interior rock from a mine. That's why we have many scientific projects around the world that penetrate into deeper depth to explore the conditions. There are projects like Deep Ocean Drilling Project and Integrated Ocean Drilling Project to gather large volume of information and analyze materials for understanding the interior of Earth. Just a quick information here. The deepest drill is at Kola, which is in Arctic Ocean, and it has so far reached a depth of 12 km. The crust, that is the upper layer of the Earth, is itself 30 km deep from the continent, not from the ocean bed. It is that thick. So 12 km is just half of it, yet it has been the deepest drill till date. This is something to think about. So this was the drill part for gathering information. Another way is to analyze the material that comes out automatically from the interior. I'm referring to the volcanic activities. Volcanic eruption forms another source of obtaining direct information. So whenever there is any volcanic eruption, a sample of the magma is tested around the globe by scientists to determine its components. However, it is difficult to assume the depth of the source of such magma, meaning from where this magma has evolved. Is it right from the core or is it somewhere in between the Earth's layers? So there are some limitation when the quest of knowledge is dependent on direct sources. However, it is far better than going in person inside the Earth, which can otherwise be fatal. Now let's read about some indirect sources that gives us information about the interior. So the temperature and pressure increases as we go from the surface towards the interior in deeper depths. Now this information was observed through mining activities. Another very important information we know is that the density of the material also increases with depth. Now that we have all these facts, scientists have developed an estimation as to what the temperature, pressure and density of each layer will be with respect to the total thickness of the Earth. Again, these are estimation, that is approximate values. So here you see a lot of mathematical concept comes into play. That's why it is referred to as indirect sources. Another source of information are the meteors. Have you ever heard of meteor shower? That's the time when meteors reach the Earth. Since they are not part of Earth, you must realize that they are solid bodies developed out of material similar to that of Earth. Hence, this becomes yet another source of information about the interior of the Earth. Then other indirect sources include gravitation, magnetic field, and seismic activity. So gravitation force is not the same at different latitudes. It is greater near the poles and less at the equator. And the reason is because the Earth is not a perfect sphere. It is bulged at its center. So its distance from the center at the equator is comparatively more than the poles. The gravity keeps on changing as we move from one place to another, but it is maximum at the place where it is nearer to the center. As a result, the gravity is more at the poles and least at the equator. Now this change in gravity reading is called gravity anomaly. The gravity values also differ according to the mass of material. And we know that materials are unevenly distributed on Earth. Moments back I told you that gravity is more at the poles than at equator. Therefore, we can say that the materials found at the pole have higher mass compared to the materials found at equator. And that's why you will see North and South Pole are rich in natural resources. The next topic is about earthquake, and I've made a separate video on it. I'll link the video in the description and you can have a look at it. So now we are going to move on to the topic types of earthquake. The first one is a common one and is known as tectonic earthquakes. Whenever you hear the word tectonic, we are referring to the breaking of the crust part of the Earth's surface. So the breaking of the crust part is due to sliding of rocks that creates a fault, and that's what the entire tectonic earthquake is all about. The second one is recognized as volcanic tectonic earthquake. These are confined to areas of active volcanoes. Now you see this word tectonic again associated with volcano. So you know that volcanoes are like a ventilator of the Earth's surface from where the magma comes out. Whenever the magma comes out of the volcano, the movement results in pressure changes in the rock around where the magma has experienced stress. And at some point the rock may break or move, and when that happens, it's tectonic, wherein the crust part of the Earth's surface breaks, creating a fault. The third one is called as collapse earthquakes. These take place in areas of intense mining activity. Here the roofs of underground mine collapse, causing minor tremors. As we know that mining involves a lot of explosion of rock, and that produces seismic waves. These waves are called tremors. The fourth one is called explosion earthquakes. Now by the word explosion, it's evident that we are talking about something man-made or manually created. Due to the explosion of chemical or nuclear devices, seismic waves are produced, and these waves produces tremors. These tremors move and break the rocks, and that creates an earthquake, which is a total manually created. And the fifth one is reservoir-induced earthquakes. The earthquakes that occur in the areas of large reservoirs are referred to as reservoir-induced earthquakes. To explain this, I'll have to show you an illustration. You know what a reservoir is, right? Now when reservoirs store water, and I mean large quantity of water, that huge quantity of water creates pressure. Now where does the pressure hits? It hits on the wall, the surface of the reservoir. Now those walls in turn creates pressure on nearby rocks. If at all there is a fault, meaning a crack in the crust, because you never know where the faults and cracks are inside the crust. So if at all there is one nearby to the reservoir, that will push large chunk of rocks, and that fault may increase in size. There you go, we have a reservoir-induced earthquake. The next topic that we are going to talk about is measuring earthquakes. A seismograph is used to detect the vibration caused by an earthquake. The strength or magnitude of an earthquake is measured using the Richter scale on an intensity scale of 0 to 10, 10 being the highest. The intensity of the earthquake is determined by a Mercalli scale, which ranges from 1 to 12. So Richter scale determines the magnitude of the earthquake, and Mercalli scale determines the intensity of the earthquake. Remember that. Now let's read about the effects of earthquake. So earthquake is a natural hazard. So these are some effects of earthquake. I want you to quickly look at them. There are some 10 to 12 of them. Just have a look at them. Now in this list, the first 6 have to do with landforms. Because if you see ground shaking, differential ground settlement, land and mudslides, soil liquefaction, then ground lurching, avalanches, all these have links with landforms. And the remaining effects of this list are concerned with the life and properties of people in that region. So yeah, just have a look at this list of some hazardous effects of earthquake. Earthquake with high magnitude can cause heavy damage to the life and property of people, and not all the parts of the globe necessarily experience major shocks. A magnitude of 8 plus is very rare and can occur once in 1 to 2 years, whereas those of tiny types occur almost every minute. So basically it is saying that there is a constant change that is happening inside the surface of the earth, and those little changes are creating tiny tremors. The next topic is about the structure of the earth. I've again made a separate video on it. The video link is in the description. Please have a look at it. We now move on to the next topic, volcanoes and volcanic landforms. We all know what a volcano is. We have seen pictures of it releasing gases, ashes, then molten rock material, lava to the ground. So the question now is, where does the magma inside the volcano comes from? So let's understand it with a simple illustration. Below the volcano is the crust, which is the upper layer of the earth. After crust, it's the mantle. Actually, the mantle is divided into two parts, if you remember, upper mantle and lower mantle. And we have also read that the upper mantle is also called as asthenosphere, where astheno means weak. Here the rocks are in molten fluid called magma and is moving here and there, and that's what makes the crust unstable, causing seismic activities. So it is from this layer, which is the asthenosphere, from where the molten rock comes out of the volcano as lava. The material that reaches the ground includes lava flows, pyroclastic debris, volcanic bombs, ash and dust and gases such as nitrogen compounds, sulfur compounds and minor amounts of chlorine, hydrogen and argon. Now volcanoes are of different types and they are based on the nature of the eruption and form. I have another separate video on different types of volcanoes and their landforms. The video link is in the description, just have a look at it. The reason I make topics like these in separate videos so that they can be referred easily by anyone at any time. You don't have to watch a long video like this one and then get to a point to understand one individual topic. So I hope you don't mind when I tell you to go to so and so link for so and so topic. So don't forget to watch that video. As of now, we are done with this chapter. This chapter dealt with the interior of the earth in a nice comprehensive manner. I hope you found this video informative. The question answer of this chapter can be found on the website. The link is there in the description as well. As usual, thanks for watching and I'll see you in the next one. If you enjoyed these videos and see a purpose behind watching them, please like the video and comment down below. Until then, catch you guys later and talk to you guys on the next one. Peace.